Ask my instructor 8.2.15. To find this integral, we're going to first observe that the odd power of cosine allows us to pull cosine 5x out. Why is this useful? Well, I know that the derivative of sine is equal to cosine. And so I'm going to write the integral in terms of sine. Let u equal sine 5x, and then I will have what I need. I will need, if u equals sine 5x, I'm going to need du equals 5 cosine 5x. And by pulling out that cosine 5x, I'll have the du that I need. I'll show you what I mean. For now, just pull a cosine 5x out. When I do that, my cosine to the 3 is broken up into two pieces, cosine squared and cosine. So those two multiplied together make cosine to the 3. I now need to have the rest of the integral to be in terms of sine. We will use the Pythagorean identity to write cosine squared in terms of sine. So here's your Pythagorean identity. And instead of our cosine squared, I now have 1 minus sine squared. Now the sine negative 2 5x, instead of that, I'm going to put that in the denominator. That's more of a personal preference. You might handle it differently. So I have that cosine 5x that I pulled out, and everything else is written in terms of sine. So I'm ready to make my substitution. Let u equal sine 5x. And so du equals 5 cosine 5x. And instead of cosine 5x dx, I'm just going to substitute 1/5 du. So as I said, in making this substitution for u, I need the function cosine 5x to be part of du. So that's why having an odd power is very helpful. Okay, it's time to do the substitutions. Instead of the signs, I'm going to put in u. And instead of the cosine 5x dx, I'm going to put in 1/5 du. You ready? Here we go. When I get to here, then it's fairly straightforward calculus 1 work. I'm going to pull out the 1/5 and then rewrite the integral in this manner. And I'm working my way to using the power rule. So I'm ready to use the power rule. The antiderivative of u to the negative 2 minus 1. Now a little bit of cleanup would be nice. And then I don't, let's see, let's pull those negatives out, okay? And this is what I get. Now substitute back. And this is what I get. which you can rewrite this way. I don't particularly care, but some people like to rewrite it that way. So we're all done. Uh, and the whole key to this was the fact that one of the trig functions was to an odd power, and we pulled out that one piece that would be part of our du when we did a substitution. Okay, take care and have a great day. Let me know if you have any questions.